So here I have two position versus time graphs, and before we do anything about comparing these two graphs, let's go over the basics first. So we can see that we have an italicized x versus t, and what this is saying is that the italicized x stands for position in physics. So this is position versus time, and position is measured in meters while time is measured in seconds. So over here we see the same thing, and it's going to be like this for all position versus time graphs. So on the x-axis we have time measured in seconds, and then on the y-axis we have position measured in meters. And for this graph we can see that we have a line with a slope of 0, and our initial position is going to be the y-intercept, or 5 meters. And we have the same initial position over here too. So this has a slope of 0, while this graph has a slope of 1. And we can see that because for every 1 second, our position is changing by 1 meter. And same here. So we're going to use this standard equation, position equals initial position plus velocity times time, to describe what's going on in these two graphs. So for this blue graph, we're going to keep this variable position. So position equals initial position. Now we can find that from this graph here, which is 5 meters. So 5 meters plus velocity. So the velocity of a position versus time graph is going to be its slope. And like we said before, our slope is 0. So this is going to basically be erased out, because 0 times anything is just going to be 0. So our equation for this graph is just position equals 5 meters. And what this is saying is that our object is going to stay stationary. And this makes sense because when we look at the graph as time goes on, our position remains at 5. So our object is basically just going to stay at 5 meters for the whole time. And then over onto this graph, we can see that our initial position is still 5 meters, but our slope is 1. So we're going to plug that into our velocity. So we're going to have plus 1 meter per second, because velocity is measured in meters per second, times time. So since time is measured in seconds and we're multiplying the unit of seconds times the unit of meters over seconds, the seconds are going to cancel out. So we have this times however many seconds we have, and these cancel out. So now we have meters plus however many meters we get from this term, and that's going to equal our position. So let's say that if we wanted our position at t equals 1, we can do our 5 meters plus 1 meter per second times 1 second, and so these seconds cancel out, so we get 5 plus 1, which is 6 meters, and we can see that from our graph here. So we can also compare this standard equation to our y equals mx plus b equation from math. So y equals mx plus b. So here our b is going to line up with our initial position, because b is our y-intercept. And like we've seen here, our y-intercepts are the same thing as the initial position. And velocity, as we said, is the slope of the graph, and that's going to line up with m, which is also the slope of any graph. And then x, the variable x, is going to line up with our variable t. So just in case you ever forget about this, just think about y equals mx plus b, and you'll remember this in no time.